Welcome viewers once again. This is the episode number 2. For episode number 1, you can go to my channel and then you can see my previous video. This is the second video of Starstruck lecture series. Today as well we will discuss on 5 topics which are very basics as far as structural engineering is concerned, as for Eurocode, and this is the episode number 2, so let's dive in. Before starting anything, I want to reintroduce myself once again because this is very new to you. I am very new to you. So I am a structural engineer by profession. I have graduated from West Bengal University of Technology in the year of 2014, and for these 9 years I have been working as a structural engineer. You can have a look with the companies I have served for, and at present I am pursuing structural engineering with materials MSc from Nottingham Trent University. So yeah, basically I am a student right now, but I have 9 years of experience, so thought of sharing some knowledge with you, as simple as that. So what are the topics we will discuss today in this episode? So these are the basic topics. Number one, actions, which is the most important thing I would say among these 5. The first is actions. The second one is combinations of actions, and the third should be representative value of an action. But to understand the representative value of an action, you have to understand what is a reference period. So I have kept reference period in the third in the list. So the first is actions, the second is combination of actions, the third is reference period, the fourth is representative value of an action. What these are will shortly see, and the fifth one is effect of actions. So let's dive into what the actions are. So actions are basically two kind of things. One is set of forces which are applied on the structure directly. So suppose you are putting a brick wall, you are putting a furniture, you are putting a load which is directly acting on the structure. So that is a direct action. So you can say it like this, that set of forces or loads applied to the structure, that is a direct action. Second one is set of imposed deformation or acceleration. Okay, that can also be act as an action. Like say there are moisture variation. Okay, there are temperature changes. These are not direct actions. Say for uneven settlement, earthquakes, and even there are construction faults. Okay, these kind of things I mean uh, acts on act on a structure in an indirect manner. So these cannot be called as a direct action. These are under indirect action. So there are many kind of sets where you can say this action versus this action, this action versus this action, depending on which criteria you are dividing those. So we will first see fixed action versus free action. Look, I have color coded this into two sets. Fixed action and free action are of same color. Permanent action and variable actions are of same color. So fixed action versus free action. So this separation is on the basis of the distribution over the space or the position. Okay. So what is fixed action? Fixed action that has a fixed distribution and position over the structure or structural element. So it is not going to move. That is a fixed thing. Like you can say that you have installed a solar panel on your roof. So that may be a fixed action, right? It is not going to move anywhere else. But say in a residential building, the live load, right, like the loads coming from the people living there, they're always moving, they're not fixed, right? So or the furnitures, they may be moved, right? So these actions are not fixed. These are free actions. So free action are those actions which may have various spatial distribution over the structure. So over a space, it may have a various spatial distribution. The distribution is not same, right? Okay. So another aspect we can see that there is like the variation in magnitude. This is a spacious variation based on which we have divided in as a fixed action or free action. But also we can divide it like this: permanent action versus variable action. And also keep in mind that variable action we denote it by G, and variable action we denote it by Q. So what is a permanent action? Permanent action is action that is likely to act throughout a given reference period, and for which the variation in magnitude with time is negligible. Okay, or for which the variation is always the same, that is constant or monotonic, until the action attains a certain limit value. So basically what it is saying now, yeah, there is a term here which is we are going to see next, which is the reference period. So for now, let's just suppose that reference period is just a duration. Okay, now what is permanent action? Permanent actions are those actions which, I mean, the variation in which it is not being varied, it's not varying. Okay, it is for that during that period, during that reference period, it is either constant or the variation in it is so monotonous that it can be negligible. It can be taken as negligible. Okay, so this there is no variation, I mean significant variation in magnitude. That those actions can be termed as a permanent action. Self-weight may be one kind of permanent action, right? And the super dead loads, right? Super dead load means the floor finish or those ceiling plaster. This kind of things can also be treated as a permanent action, because these loads are not going to change in future, most likely are not going to be changed. Okay, now in contrast to permanent action, there is variable action. The variable action is very simple: action for which the variation in magnitude with time is neither negligible nor monotonic. So basically you can say that this is significant variation of loads. So variable action is such kind of action which is varying with time, varying in magnitude, right? So variable actions are which actions? Like live load can be a variable action, wind load can be a variable action, snow load can be a variable action, fire load can also be a variable action, because they are there may be a variation, right? Okay, in the next section there are three actions which can be subdivided on a basis of a single criteria, which is the acceleration generated from that action. Okay, so there are three. First one is static. Static action is pretty simple. It doesn't cause any significant acceleration in the structure. Sorry for the interruption. So there are other two actions as well. Second one is quasi-static action, and third one is dynamic action. So quasi-static action is one kind of dynamic action. Okay, so let's see what is a dynamic action first. So dynamic actions are those actions which cause significant acceleration of the structure or structural member. So exactly opposite to the static action. Static action doesn't generate any significant acceleration. Dynamic action does. Now what is a quasi-static action? Quasi-static actions are those dynamic actions which can be represented by an equivalent static action. So if any kind of action, any kind of dynamic action can be represented, or represented by an equivalent static action. Okay, I mean if you have done the equivalent lateral load calculation, you can understand what I am talking about. The action is actually a dynamic action, but for our easy calculation, or for our easy in calculating things, we have transferred it, we have converted the things into one kind of static action calculation. So that is one kind of quasi static action, which is basically a dynamic action, but for our ease or for other reasons we have converted it into equivalent static action. Okay, I hope I can make you understand this. In this slide, there are three types of actions, but they are not related to each other, and their names say it all. Like accidental action, those actions which are of short duration but of significant magnitude. Okay, like fire is one kind of accidental action, usually of short duration but of significant magnitude, that is unlikely to occur on a given structure during its design working life. Oh, by the way, if you don't know what a design working life is, you can go back to the previous video. You can check there. I have discussed about the design working life thing. Okay, so yes, so accidental action is something which is of short duration, but but it has a significant magnitude, and to it is not going to occur in the design working life for that structure, given in that structure. Okay, so seismic action arises due to seismic events like earthquakes and so. And geotechnical actions transmitted by the structure to the structure by the ground, fill or groundwater. So there are actions which are given by soils or uplift. These kind of actions are maybe under maybe categorized under geotechnical action. Okay, so these are the actions. Okay, so the next topic is combination of actions. This is very simple. So say there is a structure or a part of a structure, and a single part of structure is not under a single load, right? There are kinds of loads, and also they are not acting in the same direction, and also they are not acting in a same spatial distribution. Some load is in the form of line load, like wall kind of thing. Some loads are kind of point loads, like if a column is arising from a midpoint of a beam. Some loads are kind of area load, like floor loads and wind load on a wall, vertical wall, and also they are not acting at the same time. So how will we take into consideration that what is the most adverse effect? Because we have to design for most adverse effect, right? We are not going to design something and say uh, there are more I mean dangerous situations arises, and then what happens? The structure get failed. Okay, we don't want this kind of design, so we have to design it for the most adverse effect. So for that we have to combine those actions. Now how will we combine it? The techniques we will learn in future videos, but for combining those actions we use this technique. So this is called combination of actions. It is a set of design values. Now what is design value, we will again see next in this video itself. So set of design values used for the verification of the structural reliability for the limit state. Now again, for understanding limit state you have to go back in our previous video. So there are two kinds of limit state, right? ULS and SLS. There are also two kinds of SLS limit states. So for under a specific limit state, to verify that the structural reliability is there or not, we have to do simultaneous we have to do simultaneous influencing actions. We have to take into considerations by taking a set of design values. So though that set of design values is called combination of actions. Many people understand it like that uh, this plus this, I mean dead load plus live load plus wind load. This is not like that. To be very honest, those things cannot be just algebraically summed up, because they have different kind of magnitudes, they have different kind of directions. You can take the effect of those actions, you can take the effect of those actions in a single direction and then sum it up, but that is not a combination. The combination is that you are considering a set of design values. Say you are taking dead load, you are combining it with live load, you are combining it with wind load, right? Now it is very obvious that wind load and live load is not acting in the same direction, right? But how we are adding it up? So because we are adding its effects, so that's why these, try to understand this, that the effect of those actions are combined up, not those actions, right? So this is combination of actions is the set of design values used for the verification of the structural reliability for a limit state under the simultaneous influences of different actions. Okay, influence of different actions. Okay, keep in mind. Okay, next one is reference period. uh, this is just a single line definition, but the thing is huge. Those who have studied statistics, they can understand what a reference period is. So there are some variables, there are some values which we had to, I mean, we cannot definitely measure it. So we had to measure it by statistical procedures. So for assessing those statistical uh, a procedure for assessing those variables, we had to choose a period or a time period or a duration, right? So that is called a reference period. So what is the definition saying? Uh, Chosen period of time that is used as a basis for assessing statistically variable actions and possibly for accidental actions. So we'll see, we know what is an accidental action already. So variable action and accidental action, for both of these, we, sorry, for assessing variable actions and accidental actions, for both of these we have reference period. Okay, so this is a chosen period of time just for statistical basis, nothing else. Okay, now this is going to be interesting. Representative value of an action. So each and every action, I mean basically variable actions, they have three representative values. Let's say the first line, value used for the verification of a limit state. It is only used when a verification is required, either for ULS or for SLS or for RSLS or ISLS, whatever it is. We have to use it when a verification is required. Now uh, there is a value which is called characteristic value. So our representative value may be the characteristic value or an accompanying value. So if we can I mean symbolize action with F. Okay, I have not mentioned it here. Like permanent action is symbolized by G, various variable action is symbolized by Q. Action is also symbolized by symbol F, the letter F. Okay. So if we have the characteristics value of it, so the just catch the pronunciation, characteristics, so from there we have K. So if K is the characteristics value of F of an action, okay, and an accompanying value. What is an accompanying value? Accompanying value may be three types of accompanying value, but we generalize it. with the letter psi. Okay, so this psi symbol is multiplied with the characteristic value, right? So accompanying value can be of three types. So representative value may be of two types. One is characteristic value and another is accompanying value. Accompanying value is can be found by multiplying the psi factor with multiplying uh, with fk, that is characteristics value of an action. Okay, now psi can be of three types: psi 0, psi 1, psi 2. Psi 0 is combination value of a variable action. Psi 1 is also frequent value of a variable action. Psi 2 is for quasi-permanent value of a variable action. All three are for variable actions. So again, psi 0 is for combination value, psi 1 is of representative frequent value, and psi 2 is for quasi permanent value. Now this okay, so you have to understand that except combination value, okay, except combination value, that means for frequent value and quasi permanent value both, these values are determined. Okay, but in case of combination value, it is not determined, it has been chosen based on some statistical calculations, statistical basis. Okay, so based on some statistical study, the combination value is chosen, or you can say phi 0 is psi 0 is chosen. It is chosen in such a way that the probability that the effects caused by the combination will be exceeded approximately the same as by the characteristic value of an individual action. Okay, so if we look into it, this is a chosen value which is determined on the statistical data, statistical study. It is chosen in such a way that the probability of which that the effects caused by the combination, the effects caused by the combination will be exceeded is approximately or the same as by the characteristic value of an individual action. Okay, it is, I think it is pretty much clear from the definition. Now what is psi 1? Psi 1 is calculated, I mean determined. Okay, so this value is determined in such a way that the previous one was approximately the same, but in this case it is exceeded is only a small given part of the reference period. So here we have to introduce the reference period. We have understood what our reference period is. So frequent value is a value which is determined in so far as it can be fixed on a statistical basis, so that either the total time within the reference period during which it is exceeded is only a small given part of the reference period, or the frequency of it being exceeded is limited by a given value. So either of these two can be limited. One may be the total time that can be limited, and another one is the frequency that can be limited. So the total time may be limited by a very limited in such a way that a very small given part is exceeded from the reference period, but or the frequency can also be exceeded, it is also limited by a small amount, a given value. Okay, now the third one is quasi permanent. Now this is also a determined value, but there is a difference between frequent value and quasi permanent value. Quasi permanent value is determined so that the total period of time, okay, the total period of time for which it is being exceeded. Look, this is being exceeded for a time in all those cases. The first one, it is not exceeding at all. The second one, it is exceeding, but it is limited by a limited period. In the third case, which is the quasi permanent, it is a large fraction of the reference period. So in the next episode, maybe I can draw a graph or something which you can understand that if this is a reference period, combination value should not be exceeded from it. It is chosen in such a way. But frequent value can be exceeded by a limited amount. Okay, maybe the exceeding amount, the extra amount may be there, but that should be under a limited period or limited given value. Okay, in terms of frequency it should be limited in terms of value, but in terms of in the case of total time, it should be limited by a fixed time, limited time. Okay, but in quasi permanent, the one which is exceeding, it is a large fraction of the reference period. So if you compare the reference period with the time exceeding from the reference period, that will be large, that will be a large fraction of the original reference period. So I think the idea is clear. If it is required, if you ask me for it, I can give you a graphical representation. What is the difference between combination value, frequent value, and quasi permanent value? Okay, and also I will request each and everyone to please comment. I am seeing, I am noticing that for the first video, you have liked so much, you have subscribed for it, but you are not staying in the video. Maybe after 2 or 3 minutes you are going. I don't know why, but if you are more interactive, if you think I am lacking somewhere, please let me know in the comments so that I can add those up and improve my next video. Okay, so next, the last topic, I think, yes, the last topic is effect of actions. So during combination of actions, I was talking about this. So effect of actions are those which are generated due to actions. Okay, like internal forces. So internal forces means you know what is an what is an internal force, right? Internal forces, internal stresses, strains, okay, moments. So internal force, internal moments, all those are there. Remember, why I am telling internal forces, because those are the reactions of a structure. Say someone says you, someone speaks wrong things to you, and you are reacting, right? So this is one kind of excitation. So when a structure is being excited by an external application of loads, it is also get excited, and for that there are some internal reactions generated. Okay, what are the internal reactions? These are internal forces, internal moments, stresses, strains, and also the structure gets deflected, the beams, the sections get rotated. So this can be happen to the whole structure as a whole, and also to beams, columns, plates, cantilever, slabs, stairs, lintels. Each and every member, each and every member will also feel the effects of an action. Okay, so yes, these were today's topics which I was going to cover, and I have covered all. So thank you for showing so much love once again. I had not reached my target. So my target for views is still same, 500 views. If you like this video, if you think this video is worthy of liking, of viewing, please kindly view this and share this with amongst your friends, because Eurocode is such a topic which is not generally be available in YouTube. So you can study that by watching my video. And also I'm targeting for 70 subscribers. I think you will going to subscribe my channel. But yes, that is one more point I want to address. After pressing the subscribe button, why you are subscribing? You are subscribing so that you can get my videos, you can get the updates of my video. But until or unless you are pressing the bell icon, when I upload my new video, the YouTube will not notify you. So if and only if you press the bell icon after subscribing, then only you can get notified when I upload a new video next time. So thank you each and everyone for supporting me, and please let me know what are my faults, what are the points to improve, any suggestions in the comment box so that I can read and improve in future. Thank you. Goodbye.